in the name of God. About our course, we started in previous session. The name of this course is Digital Image Processing, or DIP. Our book is Mastering OpenCV4 with Python, a practical guide covering topics from image processing, augmented reality to deep learning with OpenCV4 and Python 3.7 by Alberto Fernandez Villa. So in previous session, I explained to you how to install Anaconda, which is a package manager, how to install OpenCV, which is a computer vision library and an open source computer vision. And I explained to you how to install Spider, which is an IDE for writing, editing, and running Python programs. Also, we wrote a simple program to read and display an image. So I explained you until page 40. Okay, this is the book, PDF of the book. So we should say from this page 40, as I told you already, Python is a programming language. It is an interpreted high-level and general-purpose programming language with a dynamic type system and automatic memory management. So it is an interpreted language. The official homepage of the Python programming language is this page, Python. The popularity of Python has risen steadily over the past decade. This is because Python is a very important programming language in some of today's most exciting and challenging technologies. Artificial intelligence, or AI, machine learning, neural networks, deep learning, Internet of Things, IoT, and robotics, among others, rely on Python. Here are some advantages of Python. It is considered a perfect language for scientific computing, mainly for 4 reasons. It is very easy to understand. It has support via packages for scientific computing. It removes many of the complexities other programming languages have. It has a simple and consistent syntax. Okay, let's skip this part. Of course, I told you already that Python has a lot of pre-built libraries like NumPy, SciPy, scikit-learn for every need of your AI project. It is an independent platform which allows developers to save time in testing on different platforms. Okay, let's go. Introducing OpenCV. OpenCV is a C++ programming library with real-time capabilities, as it is written in optimized C++. It is written in optimized C++. The library can profit from multi-core processing. A theoretical introduction about the OpenCV library is carried out in the next section. So why OpenCV library is popular? Here are some reasons for its popularity. Open source computer vision library is open source. OpenCV BSD license is free. You don't have to pay for it. Scientific library for image processing. It has more than 2,500 optimized algorithms, including state-of-the-art computer vision algorithms, machine learning and deep learning support. The library is optimized for performance. There is a big community of developers using and supporting OpenCV. It has C++, Python, Java, and MATLAB interfaces. The library supports Windows, Linux, Android, and Mac OS. It also has fast and regular updates. Every 6 months, official releases occur. Okay, let's go ahead. So, contextualizing the reader. In order to contextualize the reader, it is necessary to establish and set the bases in relation to the main concepts concerning the theme of this book. The last few years have been considerable interest in AI, artificial intelligence, and machine learning, specifically in the area of deep learning. These terms are used interchangeably and very often confused with each other. For the sake of completeness and clarification, these terms are briefly described next. So, what is AI? AI refers to a set of technologies that enable machines or computers or robotic systems to process information in the same way humans would. So, of course, there are different definitions for AI, but here this book is used this definition: a set of technologies that enable machines to process information in the same way humans would. The term AI is commonly used as an umbrella for a machine technology in order to provide intelligence covering a wide range of methods and algorithms. Machine learning is the process of programming computers to learn from historical data to make predictions on new data. So this is the definition of machine learning: the process of programming computers to learn from historical data to make predictions on new data. Machine learning is a subdiscipline of AI and refers to statistical techniques that machines use on the basis of learned interrelationships. On the basis of data gathered or collected, algorithms are independently learned by computers. These algorithms and methods include support vector machine, decision tree, random forest, logistic regression, Bayesian networks, and neural networks. Neural networks are computer models for machine learning that are based on the structure and functioning of biological brain. An artificial neuron processes a plurality of input signals, and in turn, when the sum of the input signals exceeds a certain threshold value, signals to further adjacent neurons will be sent. Deep learning is a subset of machine learning that operates on large volumes of unstructured data such as human speech, text, and images. A deep learning model is an artificial neural network that comprises multiple layers of mathematical computation on data, where results from one layer are fed as input into the next layer in order to classify the input data and or make a prediction. Therefore, these concepts are interdependent in a hierarchical way, AI being the broadest term and deep learning the most specific. This structure can be seen in the next diagram. So here we wanted to show the relation between these words. But deep learning is a subset of neural networks. Neural network is a subset of machine learning, and machine learning is a subset of artificial intelligence. But what is computer vision? Computer vision is an interdisciplinary field of artificial intelligence that aims to give computers and other devices with computing capabilities a high level understanding from both digital images and videos, including functionality for accurate processing and analyzing digital images. So it is an interdisciplinary field of artificial intelligence. And it works on both digital images and videos, including functionality for accurate processing and analyzing digital images. This is why computer vision is partly another sub-area of artificial intelligence, heavily relying on machine learning and deep learning algorithms to build computer vision applications. Additionally, computer vision is composed of several technologies working together: computer graphics, image processing, signal processing, sensor technology, mathematics, or even physics. Therefore, the previous diagram, this diagram, which shows the hierarchical relationship between these terms, artificial intelligence, machine learning, neural networks, deep learning. So the previous diagram can be completed to introduce the computer vision discipline. So we complete that diagram. We put computer vision here. So, and it includes or uses different fields. Okay, so it was a very short introduction to AI, deep learning, machine learning, neural networks, computer vision. So they are all connected to each other, okay, partly. So let's continue a theoretical introduction to the OpenCV library. OpenCV is a programming library with real-time computer vision capabilities, and it is free for both academic and commercial use, BSD license. In this section, an introduction about the OpenCV library will be given, including its main modules and other useful information in connection with the library. OpenCV since version 2 is divided into several modules, where each module can be understood in general as being dedicated to one group of computer vision problems. This division can be seen in the next diagram, where the main modules are shown. You see here core, image processing, image codecs, high GUI, video, and so on. So OpenCV modules are shortly described here. Let's I skip this part. Okay. Regardless of whether you are a professional software developer or a novice programmer, the OpenCV library will be interesting for graduate students, researchers, and computer programming in image processing and computer vision areas. The library has gained popularity among scientists and academics because many state-of-the-art computer vision algorithms are provided by this library. Additionally, it is often used as a teaching tool for both computer vision and machine learning. It should be taken into account that OpenCV is robust enough to support real-world applications. This is why OpenCV can be used for non-commercial and commercial products. For example, it is used by companies such as Google, Microsoft, Intel, IBM, Sony, Honda, research institutes in leading universities such as MIT, CMU, or Stanford provide support for the library. OpenCV has been adopted all around the world. It has more than 14 million downloads and more than, this statistics are for 2 years ago, 2-3 years ago. Anyway, it is explained about some applications of it. Let's skip. Okay, about the installation I explained you already. OpenCV, Python, and AI related packages can be installed on most operating systems. We will see how to install these packages by means of different approaches. Of course, you can use all of Jupyter Notebook as well. In this section, you will see how to install Python, OpenCV, and any other package globally. The specific instructions are given for both Linux and Windows operating systems. So if you want to install Python on Linux, you can use this command. In Windows, you should go to Python downloads. I click it. Of course, I explained you that you install Anaconda. So let me skip this part. Of course, this is an installation of Python from its website. At the moment, the latest version is this version. You can click it and you download it, and of course install it. You can install pip. It asks you tick pip. Pip is a package manager, but there are different ways. You give the root. If you want, you can change it, but in Linux, so when you install Python, then you can go to the command prompt and write pip install numpy or pip install OpenCV contrib Python. To install numpy is a package, and OpenCV, and also if we will use also matplotlib, you should install this as well. So there is another way to install virtual environment. Let let me that I skip these parts. There are some IDEs that you can use. For example, there is PyCharm, there is Spider. We will use Spider. You can use other things as well. When you install Python itself, it also has a simple IDE. You can use that also. So if you like, you can install PyCharm. Let me skip these parts. You can use Anaconda or Miniconda. Conda is an open source package management and environment management system. Environment management system actually provides virtual environment capabilities that runs on many operating systems, for example, Windows, Mac OS, and Linux. Conda installs, runs, and updates packages and their dependencies. Conda can create, save, load, and switch between environments. Anaconda is a downloadable, free, open-source, high-performance Python and R distribution. Anaconda comes with Conda, Conda built Python, and more. Bismillah ar-Rahman ar-Rahim. In the name of God. It is downloaded and wait a second. I should bring it here. Here in this page, you can click download and it will be downloaded, the Anaconda individual edition, and it will be installed. So this version is not here anymore. I think this is it has Python 3.8 at the moment, and this is another version, but you can install the last version. It shouldn't be necessarily this version that the book says. So when you install, it asks you want Python 3 or Python 2. You should select Python 3. After you are finished installing, in order to test the installation in terminal or Anaconda prompt, run the following command, conda list. For a successful installation, a list of installed packages appears. So if installation goes well, then you write conda list on Anaconda prompt or terminal, then a list of installed packages appears. As mentioned, Anaconda and Miniconda comes with Conda, which is a simple package manager similar to apt-get on Linux. So we have a package manager. When you install Anaconda, you have also Conda. In this way, we can install new packages in terminal using the following command. You write conda and then you write install and then the package name. Existing packages can be updated using the following command: conda update package name. You can search for packages using the following command: anaconda search -t conda and package name. Let me skip this part. It is explained. This part explain environment. Let me. So I will explain the remaining parts in next video, because of the size of the video. If it's too much, it is hard to upload and download. So until next video, bye.